All right, Algebra Half, lesson 52 involves fractions and those symbols of inclusion. So far, we've restricted practice with what we call symbols of inclusion with problems that have whole numbers only. Now we're going to add rational expressions, which means they can be shown as ratios. They are fractions. What is a symbol of inclusion? It's these guys right here, isn't it? This is supposed to be a parenthesis. They get kind of long and stretched out, brackety looking when you start dealing with fractions because they're so tall. All right, let's see how we do this. Remember, what's our acronym? PEMDAS, and what does the P stand for? Parentheses, which are our symbols of inclusion. So we start with whatever's in there. And what's our first step? Adding a fourth and 7/16. We need to make this be in common denominators. So then I write in my paper 3/2 is now going to be multiplied by 11/16. Next, we covered the P. We don't have exponents. Next is multiply. Before we multiply, what do we always look for? If we can cancel across it all. I don't see a way to cancel. Therefore, 3 times 11 is 33 over 32. Now I have my final 1/8. We need common denominators one more time. This can stay because that's common to 8, but how many times will 8 need to be multiplied to get to 32? 4. So top and bottom get a times 4. Now we're doing 33 over 32 minus 32 with a numerator of 4. 33 minus 4 takes me just underneath 30. Final answer, 29 over 32. Remember, adding and subtracting. Keep that denominator the same. We worked hard for it, and don't start canceling across because you can't when you're using one of these. All right, notice I kind of show in different colors all the different steps we have here. I do not want to just see this sitting on a piece of paper like you did some of this in your head somehow. There is too much, too many steps for new mathematicians. Okay? Next problem, we're going to follow the same order of operations, starting with our symbols of inclusion. Now we have rational expressions. I want you to stop the video, try this for yourself in your math notes, and then resume when you want to check against what I did. All right, pause. All right, if you're hearing my voice only 2 seconds later, that means you're not listening. If it's been about 2 minutes and you have an answer on your paper for this, then you were listening. Congratulations. Let's see how you did. I'm going to grab a maroon marker here. Start with your symbols of inclusion. And in order to add or subtract, I'm going to need to change this into eighths. Oop, that's not maroon. All right, now rewrite in your first step 1/3. And then we have 3. Take away an eighth from my 2/8 leaves me 1/8. They make it easy, no borrowing. And we still have our 1/48 sitting out there making life a little bit more difficult. Now we multiply, right? Multiply or divide. And to multiply, we're going to want to change this into an improper. So 8 times 3 is 24, plus 1 is 25 eighths. 1 times 25 is 25. And we multiply the bottom to get 25 24ths. This is maybe the first place you could have made a mistake. Check and see what you did and make sure you did as I do. Otherwise, fix it. Fix your work so you have something to look at later. And we still have our 1/48 final step, fourth and final step. Let's use pink. Can I cancel? No, because we're adding. Therefore, I simply get common denominators. I had to multiply by 2 to get that. That means I multiply the top improper fraction by 2, and I have 50 plus 1 over, keep your common denominators, 48. And you can leave it like this. You don't have to change it into a mixed number. But we do have the opportunity to reduce. And you would have found that if you switched it into a mixed number. But I can tell right now, 5 plus 1 is 6. 4 plus 8 is 12. And those are both numbers that could be divisible by 3. So we divide top and bottom by 3 over 3. And final answer is 17 over 16. Okay. That's symbols of inclusion with fractions. Why don't you do letter B for practice? Best of luck.